Learners, you are welcome to Eko Learners Support for WAEC and NECO candidates. And with you again at this time is Kamaldeen Abiona. And we want to look at yet another aspect of geometry, and that is surface area and volume of prisms.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Our objective, the objective of the lesson, students will be able to identify shapes that are prisms. Then at the same time, calculate the surface area of a prism and as well calculate the volume of a prism. All right, so what's a prism? A prism is a three-dimensional shape with a constant cross-section. Yes, when you have, so these are examples. Look at these shapes. This is a cross-section. It has been projected to this side, and that is just what we mean by prism. So it can be a triangular prism. This is a triangular prism. So look at that. It can also be a circular prism. Circular prism, have you heard of that word before? Circular prism. We also call it a cylinder because the circle is a cross section and it has been projected. So having a constant cross section. So this is a cylinder. Then we have another one. In this case, we call this, you can look at it, look at the cross section. That is how you can determine the name. Look at the cross section. What shape is this? It's a polygon, right? But how many sided? 5-sided. That's pentagon. So we can call this a pentagonal prism. So you can see how we derive the name. Yes. So look at these two. You know this, right? Yes. You call this what? A cuboid. Yes. But at the same time, you can also call it what? A rectangular prism. So that is just what you mean by prism. Like I said, I call this a triangular. I call this a triangular prism. Triangular prism. This is a cylinder, which is the same thing as a circular prism. This is what? A pentagonal prism. And the common name that we have for this is what? A cuboid. All right. So in this case, this same shape, we have a way of getting their what? The volume. The volume is just very constant to get. And that is one thing that we need to do now. What's a volume? The volume of a substance or of a shape is the what? Is the capacity. It's capacity to hold substance. So that is what we mean by the volume. So which we'll be looking at here. So what is the volume of all this? Generally, we say that a volume is what? Cross-sectional area multiplied by what? Multiplied by the height. Cross-sectional area multiplied by the height. So for this, to find the volume of this, the cross section here is a triangle. So we need the area of this triangle multiplied by this height. This is the height. To find, so it depends on the kind of triangle we have been given. So in that case, what we just need is what? The area of that cross section multiplied by the height is our volume for this. The same thing as volume for this. The volume here is what? The area of our cross section. What's the cross section? Circle. That is pi r squared. Multiplied by what? The height. The height. And that's why we have the formula as this. Wow. I hope you have got something there. Yes. If you don't know it before, that is just how we got pi r squared h. The area of this multiplied by the height. The same thing here. The area of this pentagon. Area of the pentagon multiplied by the height. Okay? Then the same thing here. The volume here will be what? Area of the base. If it is the base we are projecting upward. That's length times breadth. Length times width or length times breadth. Multiplied by the height. So that is the volume. So generally, you should be able to calculate the volume of any given prism. Alright? So, surface area and net. One of those things that we also do with solid shapes is to calculate the surface area. The surface area. How we have made that particular shape. If you need to make it, what are those things, materials that you need to bring together to make them? So, and cylinder is one of them. This is a cylinder. How can we form the cylinder? The net of a cylinder. Alright, so this is the net of a cylinder, meaning that if you need to get a cylinder, make a cylinder, you need a rectangle, and two circles. A rectangle and two circles. And from that, we can derive the surface area for cylinder. Alright, this, our rectangle is length multiplied by breadth. Is that clear? So in that case, you take that length, you fold it. You fold. So this side will meet this side. And when you fold, the length will have become what? Circumference. So the length is now what? Pi. That is 2 pi half. Circumference of a circle is what? 2 pi half. So by the time you do that, it will have formed that. So the length will now become 2 pi half. Then this is, if you need to cover both the top and the bottom, the area here is pi half squared. The area here too is what? Pi half squared. Okay? And from that, so it means if you need to calculate the total surface area, you had the area here, plus the area here, plus the area here. But before we go to total surface area, we have something we call curved surface area. Curved surface area. So meaning that the only part that is curved, and it is only the rectangle that we are what? Making to form that shape. We are what? We are folding it. So it means in that case, we say that the curved surface area, curved surface area of a cylinder is what? Length times height. That's the area of the rectangle. The area of the rectangle. Length times the height. But the length has become what? Circumference, which is 2 pi half times the height. So the circumference, curved surface area of the cylinder is what? 2 pi half h. And if you need to find the total surface area of a cylinder, it means it is what? You add everything together. 2 pi half h plus what? Pi half square, pi half square. Pi half square will give us 2 pi half square plus 2 pi half squared. And that will give us what is common from our knowledge of factorization. We can have 2 pi half is common. Half plus h plus half. So that is the total surface area of what? Of a cylinder. An interesting thing there is also that you can also count the number of faces that we have. 1, 2, 3. So that is that. Alright, we also have cuboid. And the net is this. Meaning if you need to make this is just what you need. So how many faces can you see? 1, 2, 3, 4, 5, 6. So 6. So, and in that case, if this is the length, this is the breadth, and this is the height. So you can label this. This is the height. Height. Is that clear? So we have, when you open it up, when you open this up like this, yes, if this one should come here, this is B, this is B. And the same B is here. Right? Okay? So, and the next thing is length. This is the length. So, by the time you bring them together, you realize that each side have two faces. So in that case, you can see this is also the length, and this is another thing, which is the same thing as, can you just view it? This one is here, this one is there. So this is length. This is length. All right. So which other thing? This place. So what is it? So that is what you also need to calculate. So from here we can see that this is BH. Yes. Which other one that we've been able to find out? This is LH. All right. So which other one? All these ones are H. This is also what? LH. And you can see we have been able to put the colors. This is what? BH. So how many BH do we have? 2 BH. Is that clear? So then we also have what? So this will also be what? B. So this one will be LB. This is also B, and this is what? LB. So at the end of the day, we see that the surface area, the total surface area of a cuboid is, if you add them together, you see 2 LH, all of them are having 2. So LH plus LB plus BH. So that is the formula for the total surface area of a cuboid. So the same thing for a triangular prism, the same way I've been able to do that is the same way. You can look at this. So it depends on the type of triangle you have been given. So that is what will tell us. But the basic formula, you know, is still the same thing we want to use. Rectangle will always be length times breadth. Triangle will always be half base times height. And that is similar things that are going to apply here. Okay? All right. So we have a question here. So find the value of the unknowns in the diagram below. I want to apply simply some of the formulae that we have done. So we have this shape, and we have been given the cuboid. So for the volume of a cuboid, the volume has been given. The volume of a cuboid is what? Is length times breadth times height. Okay? So the volume we have been given as 90. It should be equals to what? 6 times 3 times A. So it means 18A equals what? 90. So in that case, we divide both sides by 18. So 90 divided by 18 equals 18A divided by 18. So from there we can say that A equals 5. That is 5 centimeter. A equals to 5 centimeter. So you can see that it's interesting. All right. So based on that, you should be able to find this. It's just the same similar way that we have done this. So try that. So yes, I'm going to leave you with this practice question. Find the volume of the figure. You can see the figure. Don't forget, what do you mean by a prism? A cross-sectional area is being projected. The cross-section of a prism is projected. So this is a cross-section that has been projected. The same thing is constant. It's the same thing that is here. So with that, if you can find the area here, you are through with it. So I will leave you with that for 60 seconds. Thank you. All right. I hope you got that. Wow, fantastic. So let's look at it together. Yes, we need to find the area. How would you like to approach it? From my own approach, I can give it this way. Okay? If you look at it this way, okay? So, based on that, this is 4, this is 2. So we can call this area A and area B. That is just what we need. Just find the area. Once you get the area here, you multiply it by the height or the length or whichever way you call it. So can we do that? Area A equals, that would be what? 4 multiplied by 2. 4 times 2, which is 8 meters squared. Okay, area B is what? 2 multiplied by 2. Yes, 2 multiplied by 2. 2 times 2. That's 4 meters squared. So the total area is 12 meters squared. Hence, our volume is cross-sectional area multiplied by the length or the height, which is 12 multiplied by 6. And that is what? 72 meters squared. Meter cube, sorry. This is volume. So it will be 72 meter cube. Did you get that? Wow, that's very interesting. All right. So with this simple concept that we have looked at, I want to believe that you can solve more questions to master that particular aspect.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
All right, if there are comments, observations, or questions, you can always make use of our social media handle displayed on the screen. Thank you very much. Have a nice time.
Thank you.